Cape Canaveral has seen its share of triumphs, but tonight, Launch Complex 36 became the site of a devastating setback for Blue Origin. The New Glenn rocket, standing 98 meters tall, was preparing for a critical test under the fading light of the Florida coast. Inside Mission Control, engineers monitored every data point, unaware of the catastrophic event that was seconds away from unfolding. As the clock hit 9 p.m. and the countdown reached 0 for the BE-4 engines to ignite, the routine test took a terrifying turn. A sudden, violent orange fireball erupted from the base, quickly consuming the entire structure in a blinding flash of light. The massive transport erector and lightning towers crumbled under the force of the blast, caught in high-sped footage as the inferno spread. Miles away at Cocoa Beach, the horizon glowed with an eerie light, reflecting off the dark waves of the Atlantic Ocean. By morning, the scale of the damage was clear. Drone footage reveals a scorched landscape where a masterpiece of engineering once stood. Twisted metal and charred debris are scattered across the facility, while emergency sirens signal the start of a long investigation. While Jeff Bezos faces this monumental challenge, the industry reminds us that rockets are hard as the quest for space continues. The explosion impacts more than just hardware. Amazon's Project Kuiper satellites face significant delays following this setback. NASA's Artemis missions also rely on New Glenn's heavy lift capacity, making the road back to flight readiness a global priority. Despite the loss, the sun rises over the Florida coast, symbolizing the resilience of an industry that learns from every failure. So, what probably caused the explosion? When a rocket explodes, the cause is rarely obvious. What looks like a single explosion is often the final link in a chain of failures that began seconds or even minutes earlier. One possibility is a fuel leak. Modern rockets carry enormous quantities of highly volatile propellant. Even a small breach in a fuel line can allow gases to escape into areas where they were never meant to be. If those gases find an ignition source, the result can be catastrophic. Another possibility is engine failure. Rocket engines operate under extreme temperatures and pressures. A malfunctioning turbopump, a damaged combustion chamber, or an unexpected pressure spike can rapidly destroy the engine from within. Structural failure is another suspect. During launch, a rocket experiences intense aerodynamic forces. If a critical component weakens or breaks, the vehicle may lose stability, causing onboard safety systems to terminate the flight. There is also the possibility of software or guidance problems. A rocket relies on thousands of calculations every second. If sensors provide incorrect data or the guidance system detects an unrecoverable anomaly, the mission can end abruptly. In many cases, the explosion itself is not the original problem. It is simply the visible result of a failure that began much earlier. That is why investigations often take months. Engineers must analyze telemetry, video footage, and debris to reconstruct the sequence of events. Only then can they determine what transformed a machine built to reach the stars into a fireball visible for miles.